So I want to take a look at some SwiftUI fundamentals, just to make sure that you understand kind of why these things work, because it's helpful as we compile these pieces together. So we're not going to be looking at the preview, right? So I've hidden the canvas and other things because I just want to focus on the code itself. We'll go ahead and create some new lines just to get that off screen and really just focus what is going on here. How is it that these, 6 or 7 lines create the interface? So there are 3 main things. There's a struct content view, a variable called body, and a vstack, which then holds some other stuff, which are other views. So what are these 3 things? At first glance, all 3 of these look kind of similar because you have a thing and some parentheses and stuff inside. You have another thing, parentheses, right? Thing, parentheses, so it seems similar, but these are not the same. These are all different. So let's create some space between each of them to really isolate. So the first thing at the top will be the most familiar to you, right? From everything we've learned in Swift so far, this makes sense. We are defining a struct, we are giving it the name content view, and it is of a type view. So this content view will be of the type view. Now it is a struct, so this type is a protocol. And again, we can use that option click, right? We'll get this question mark. It's really handy. We can click the view, and indeed, this is a protocol, right? So our struct content view is conforming to the behavior of the protocol view. All right, and then it gives us some default and some examples, and you notice that the example looks a lot like the sample code that Apple starts us off with. Although theirs is even simpler, it's just a text. Ours has this vstack, but we'll get back to that. So, all right, this is a struct, this is our name, and it's conforming to the protocol view. So we're used to that. But what is the second thing? Because this looks kind of the same, but it's kind of weird. It's variable var body. So this is the name of it. So again, this is a name. We could call this, whatever I want or something like that. Just like content view can be whatever I want. But we don't want to do that for reasons, right? So we want this to be content view because the app is already expecting that. And we want this to be body. In fact, this actually has to be body because that satisfies the protocol view. So for example, if we were to comment this out and wait a little bit, or maybe we can see we already have an error. It says type content view does not conform to protocol view, right? So here we're saying that it conforms to view, but because we don't have anything, it's just empty, it's saying, no, you don't actually conform to view. So in order to fix that, we could click this little thing, and they will actually add the protocol steps for us before. And I showed you this before when we looked at protocols and structs on the Pokemon example. This is how that connects to SwiftUI, right? It's the same, they use the same pattern. But what the heck, this isn't what I want, right? So, okay, the fix-it does not always give us what we want. And I won't go into why that is, but type alias is something else, and it's trying to say, well, what type should the body be? Okay, but that's not helpful. What we want, in our case, is we want this var body. So we'll go ahead and comment this out. And we have this body. Now, what if, let's just look at the body, right? So we comment this, we add a closing parentheses, a space here. What is going on here? This doesn't look like variables that we're used to. Now, the first thing, okay, if we do this, it's still not happy because now, sure, our struct conforms to view, but this body, which whatever it's doing, it says declares an opaque return type, but has no initializer expression from which to infer underlying type. It says missing return in accessor. Expected to return some view. Some view. Okay. So that is a clue to what's going on. It's like, what the heck is this? This, it looks similar, but this is actually doing something a little bit differently. What this is saying is this is a variable that is going to be of some type view, but we expect inside here some kind of return something, some kind of return statement to return a view. Like in order for this thing to be a view, it needs to return a view inside of somewhere in here. Because these parentheses, these open and closing, it's what's called a closure. A closure is a shorthand name for a function. So what this actually is a function that is added onto the end. And so what's actually happening here is this view is equal to a function. The results of the function is getting passed into this variable. And it so happens that this variable, it's not only a view, but it is some view, which means it doesn't conform, body doesn't conform to the protocol view. It's saying that body should return a thing, something. This some is something, a opaque type is the technical term. And that thing, this sum, is what conforms to view. So it's saying body needs to return something. Well, guess what? Text conforms to view. So that's why if we say hello, we say return text. Maybe we remove this function because that's not actually valid syntax, but it was just to show you what I mean. And now, if we wait, our errors go away. So all the errors have gone because now this variable is returning a thing. And this thing, this text, happens to conform to view. And we can see in declaration of text, if we were to open in the documentation, it conforms to view. I'm not going to show that just because the screen share won't open the documentation. Okay, so to make this a little familiar, what this is doing, if we wanted to have something that we are more used to seeing, we would typically write a variable, right? And then we'd say body, and the body is going to have a type, right? And we'd say view or something, and then we'd say equals, and it's got to equal something, like it equals 5, or it equals something else, you know, some other object or something like that. Maybe text or something. That's kind of what we're used to writing. And what's happening here, as I said, it's equal to a function that returns something. So what does that look like? Let's write out the function. There's a lot of shorthand here, a lot of things implied. Let's be very explicit. Well, let's just create, it has to be a static function just because we're creating it kind of in the content view, but ignore the static for now. That's just sort of to make the example works, but it could be any kind of function. And we'll just say do stuff. This is our name of our function. And this function is going to return, again, not just a view, because you can't actually return, but it has to return something, that behaves like a view. So this function, is returning something that behaves like a view, which is exactly what the body wants. So we'll go ahead and write out what that should be, and we'll say return text hello, right? Because text is a thing that behaves like a view. So we're returning a thing that behaves like a view, and we have this function that does that. So that means we can write var body, which is going to be some view, equals, now because it's a static function, we have to say content view and then do stuff. But the idea is we're just calling that function, right? So this, and let's go ahead and, so it's saying invalid redeclaration, right? It's an error because we have two of the same thing. So let's comment this out. Okay, so now the errors have gone away. So this code does the exact same thing as this. This code hopefully should look more familiar to you. It's like we are used to writing functions. Functions have return types, they return things. We're used to writing variables, and variables we set them equal to something. In this case, it's equal to this function, which then returns, it does some stuff, and it returns a thing that behaves like a view. And that's why it can equal this variable that is a thing that behaves like a view. So this should look more familiar to you and kind of the Swift code up until this point, up until this homework. But obviously, this is a lot more to write, right? This is much more verbose. There's a lot more just stuff to write, as where this is quite simple and quite elegant. So this is why SwiftUI does it this way. It's much simpler and much easier. So by now you're probably maybe already used to writing it this way because it's what the homework requires. But essentially, this and this is the same. So we won't write this. We will write this. Okay, so that's our body. So now, oops. So now we can see that, yeah, this is actually quite different because this, we are declaring our content view, but we still have to define what it does. As we're here, we're setting a variable that already is a thing that just happens to behave like a view, and then we're saying what the function is that should return that thing. And it turns out that SwiftUI knows what you mean, so actually the return statement is not even needed, right? So the return is also implied, it's also hidden, so that goes away. So all that stuff just becomes this, which is then where we get to our next topic. So here we have this variable that needs a function that will return something that behaves like a view. Well, it turns out that text is not the only thing that behaves like a view. In fact, you can have multiple things that behave like a view. And so VStack is a special thing to group multiple views together. So let's see how that looks. Let's remove this and bring this back. All right. So now we have right, this VStack. Okay. So now we have the VStack. This is what's in the VStack. And so this is why this works, right? Because this body is only expecting one thing that applies to a view, but what if you want multiple things? We want an image and a text. How can we do that? Well, we have to put it inside of this VStack, right? Because if we, for example, if we got rid of this and we had it without the VStack, well, this will work, but the only reason this works is it is actually creating a VStack for you. It is inferring that you want a VStack. And this is why it still works, doesn't have an error, because This thing, it just wants one thing, one thing that behaves like a view. So it can't have multiple things. So this is actually embedded on a hidden VStack. Now, how do I know that? Well, because start typing return, right? If you explicitly say return, well, wait a minute, how does that work though? Because if we return this one, we never even get to this line of code, so that doesn't make sense. And if we try to return both of them, it's not going to like that. And the whole thing is, see, it wants a return type of some view, but the return statements does not have a matching type. And if you just do the second one, well, then this is not going to be used. And so it doesn't know what to do. As where this is actually being put in a VStack and returning that. And we can show that by, if we put, so we'll uncomment this, and we'll put these back in the VStack. And if we just add a return here, this will work. It's technically valid because it's just returning the one thing, which then stuff inside happens. But we don't need to write this. But you can see this is why things have to be nested inside these container views. As we already talked about, right, there's VStack, HStack, right, and ZStack, different kinds of container views. There's also other container views. We'll look at a little bit later. There's something called a list. A list is also a container view. There's something called a group, right? Okay, but then what are these things? I have a list, group, all the same kind of thing, but these things, but they don't really look like anything we're used to. Because this is a variable, but this it doesn't even have a type, right? Is this a view? Is it a some view? Like what is this thing? And usually we would expect maybe something like that. So okay, so yes, there's a lot of shorthand going on. So actually, if we again use our little option click and click list, we can see, oh, it is a struct. It's a struct, but it has some special things, has some special stuff going on, and part of that allows for the syntax. And so group, also a struct, right? VStack is also a struct. And this struct allows content to be passed inside of it. So let's just look at VStack for simplicity. What this actually is saying is let my stack equal to VStack. And again, when we create instances of things, right, you would need to do like this. This is sort of what we're used to writing. And you might even type, and we could say it is of type some view, right? This is what's going on. But the thing, VStack has this special initializer. Usually you might pass like something, right? My parameter, something like that. But the thing in the VStack, what actually is passed in here is a function. So it's kind of like what's happening with the variable. There's a function that gets passed, and then the function does stuff, which then goes inside the VStack, which creates a view, which is a struct. This isn't exactly valid syntax, but that is the idea. So a way to write this, though, is you, instead of write the functions inside, which is what's happening, there's a shorthand which says you just write them outside. And so then you can have VStack, but you can have the opening and closing. This is actually a function that's passed in as a parameter, that goes in. But we don't actually do any of this, right? And but we still cannot call this in this way. So you don't actually write, and because you never refer to the stack itself, you don't actually write it like that. So instead, you would write it like this. And they added a special shorthand, so you don't even need to write this. And so this is how you get these things. And so these vstacks or group or list, these special container views, they pass in a function, which is where you put your other views. That's just sort of how it works. But text or image are a little bit different, right? These are a little bit more what we're used to. This is like saying, right, if we want to, this is let my image equal image, right? And it turns out, yeah, it has open and closing parentheses, and there's just a parameter that we pass in, right? Now we could not do that, except it expects that we do something, right? So it's a missing argument until I put it back. So hopefully that helps explain some of this. Now, again, we don't need this, though, because these things are not referenced directly that way. We don't manipulate this, because the whole thing with SwiftUI and a struct is the struct never changes. The things never change. So there's a different way that we change things. We give interactivity, and we'll talk about that in a second. So we don't have that. But what are these then? We have dot something something. These, well, we can option click. It's a function. These are functions. And these functions have a parameter, and they return, what do they return? Some view. So these modifiers, right, we want to change the image scale, or we want to change the color. Let's check this one. Okay, also a function, right? It takes in a color and it returns some view. So these modifiers, all they are is they're special functions that always return something that behaves like a view. And so these essentially get chained onto the instance of our thing, and that's how this works. So another way to look at this would be to say, oops, you can actually have it in line, right? So this is sort of the same thing. So we have something, that thing calls a function which returns a new modified view. So this whole thing becomes a new modified view because it's returned. Then that thing which is returned then calls the next one. And so it nests like this. It keeps going, and you keep getting this new modified view until you get the thing that you want. So these modifiers, they're actually like destroying and recreating the entire view to get the modified thing that you want. And you can keep chaining, like, you know, we can add a frame or something and add more things, something like this. However, as you notice, this is not super readable, and if you have a lot of these, can get confusing, which is why we get all the way back to where we started and why it looks like how it does. So this is the same, it's just purely to make it easier to read. We put each thing on its own line. So to be explicit, right, we would say let base image equals image, open closing parentheses, passing our parameter right into our initializer. This is an initializer, system name, globe. Okay, to be really, really explicit, what's happening here looks like this. So we have our base image, or whatever we want to call it, but then we'd say let scaled image equals base image dot, and now we add the image scale, right, and large. Okay, then we would say let colored scaled image, right, both of those things equals the scaled image, and now we add foreground color dot accent color, right? So this is identical to this, right? These two things are exactly the same, but this is very explicit. And you can see it's sort of just not needed. This is just a nicer, more concise way to write it, so you sort of get used to it. This is, the SwiftUI way, and it's using the convenience features, shorthand features that the Swift language has built in, and so SwiftUI uses those to sort of great effect. And so it looks like that instead of this verbose way. So we would get rid of that. Now, what that means is the order of these modifiers does actually matter. Sometimes, right, it depends on the effect. Like if you swap these around, it's not going to change anything. But depending on the modifier you use, the order may matter. So let's look at an example. For example, if we add a border, we'll just make it blue with a width of 3. Okay, let's go ahead and bring back our canvas, bring back preview. Let's see what that looks like. Let's zoom in a little bit. Okay, so you can see there is in fact this blue square right around the blue image, so it's touching it, right? So if we add a padding here, and we'll just use the default, which is empty. Okay, so it has indeed, the padding worked, right? We can see it's kind of highlighting, and the hello world is down here, but our border is no longer on the actual border of the view, right? This thin blue line is given to us by the preview, but that's not there. And so, but if we move the border and we put it after the padding, now we can see the border is where the padding is. So the order of the modifiers matters, and that's because they are just functions applied to an instance, which is a thing that behaves like a view, in this case an image, which does indeed behave like a view. And yes, so that is why, and why it's practical is it's important to know the order of these things, and you can get different effects on your views. So one other thing I want to discuss is the nesting of these modifiers. And this is very similar to CSS, where the inner thing overrules the outer thing. So what do I mean by that? What I mean is, if we have foreground color and we say red, but you notice everything inside has become red. However, because I explicitly said the globe here to accent color and here to blue, those didn't change. But so you notice that when I get rid of the inner foreground color, then the outer takes over, right? So this is handy because let's say you're just like, I want everything inside of here to be red. I just said it once, I don't have to think about it. But if I do, in fact, want my foreground, to be something different, then I can do that. But as you notice, some things like, well, this border, it's still, you must pass in a color. So that's sort of how nesting works.